Hey, welcome to your first tutorial of Auto Entourage, a Grasshopper plugin for loading Entourage images into Rhino. We've all done this for a project, placing each entourage into a Photoshop file, adjusting for heights, adding shadows, cutting out foreground blockings, and making sure the perspective looks right. Adding entourages into architectural illustration can be tedious and time-consuming, especially for large-scale projects. Instead of manual post-production, what if entourages can be rendered alongside your Rhino model? In this tutorial, we will walk through the installation, the plugin interface, and a few worked examples showing how you can use Auto Entourage to speed up your workflow. The installation is straightforward. Simply download the plugin folder into Grasshopper's Components folder. Make sure the following files, Auto Entourage, GHPython, and Image Crop executable are present, and simply restart Rhino. Launch Grasshopper, and you should be able to double-click and type AE in crop to bring up the plugin. Alternatively, you can locate a plugin in Display and Preview. The plugin contains only two components, Image Crop and Auto Entourage. The first one crops empty margins in the Entourage images, while the second loads them into Rhino. Next, we'll go over the plugin interface and a few worked examples. In the first two examples, we will walk through the process of loading Entourage images from a folder into a Rhino model. The images we'll be working with should all be in .png format, and they should have a transparent background to begin with. Here, I have a folder of Entourage images with various margin sizes. To help us scale these entourages uniformly, we will pre-process the images using Image Crop. Let's go back to Grasshopper and have a look at the input of Image Crop. Path and out take an input and an output file paths, respectively. To them, we will connect two file path components. We can then right-click to select the input folder containing the raw images and create an output folder where the cropped images will be saved to. We will also connect a button to crop. You can optionally connect a panel to status to display output messages. When we click on the button, the component will run for a few seconds. Once cropping is completed, we should be able to see a corresponding message in the status panel. If not all of the files were processed, they're probably not in the .png format. Now, when we go to the output directory, we should be able to see that the margins of the images have indeed been cropped. Know that we only need to run this once, and we can reuse the crop entourages for future projects. Next, we will load the Auto Entourage component. The three most important inputs are path, which is the directory containing the images, image height, or the height of the entourages, and point, which are the anchor points for image placements. We'll connect the directory of the process images to path. Our second input is the image height for scaling the entourages. For simplicity's sake, we'll use 5.7 feet as an average person height, though be sure to double-check the model unit of the current Rhino model. To position the entourages, we can specify a set of anchor points. Here, we have a set of points preloaded into Grasshopper. We'll simply connect that to point. The entourages will be loaded into a new layer. For now, we can leave the layer name blank, which will default to entourage. We will also skip seed, which will modify the randomizations of entourage images. To load the entourages, simply connect a button to load and click on it. In Rhino, we see that the entourages have indeed been loaded into a layer called entourage. To see transparent background in the entourages, all we need is select objects on the entourage layer, and in the Properties, Materials, scroll down to choose Use Alpha Channel. Again, for this to work, it is important that the entourages have transparent background. Notice that if we rotate our current view, the entourages will no longer face the camera. To realign to a new camera angle, we can simply connect a button to Orient and click on it to update the entourages. Notice that loading is considerably slower, but reorienting is almost instantaneous. Luckily, as long as the parameters are unchanged, we only need to load the image once and we can reorient it as needed. All that's left now is to add some lighting and we can see how our entourages look when rendered. Next, we'll take a look at a few more involved examples to see how we can utilize Grasshopper to our advantage. Sometimes we may want more fine-grained control over our entourages. In this part of the tutorial, we'll demonstrate this in 3 more involved examples. Say you'd like to place some trees in your design visualization. The last thing you want is to have them look uniformly. We can easily vary the heights in Grasshopper. Here, I have a list of points connected to point. We can generate the same number of random heights with the random module. We can then specify the range of random heights by typing into a panel 20 space 2 space 30 and connect it to range. Next, we will use list length to get the number of points and connect that to number. We will also specify the layer name as trees. Now you're ready to load and reorient the entourages for your visualization. Occasionally, we may want to quickly populate a region with our entourages. In this example, we will look at working with multiple regions as input. Here in Grasshopper, I have a list of curves preloaded. To populate these regions with a random set of points, we can use the Populate geometry module, to which we first turn our curves into surfaces with boundary surface and connect it to geometry. Next, just for fun, we will specify the number of points in a region based on its size. To do this, we will evaluate each region's area, multiply it with an arbitrary factor, and cast it into an integer. The largest area is 10,000 square feet, so a factor of 0.1% will equate 10 points in the largest region. Now let's load the entourages. Something's not quite right, as we notice each region seems to have the same set of images. This is due to the fact that all of the regions use the same random seed, and thus they all load the same random subset of entourages. To vary the images in each region, we'll need to specify a corresponding random seed per region. We can certainly type in 16 distinct and arbitrary integers and plug it into seed. But to be more scalable, we'll simply create a range of integers based on the number of regions. Here we subtract 1 from list length because if we count from 0 to 15, we get 16 numbers. We'll also set the number of steps to 15. We see that we have 16 different integers, each corresponds to a region. Before we plug it into seed, we will have to graft it to match with the data tree structure of the input points. We'll go more in depth into working with Grasshopper data trees in upcoming examples. For now, simply load the entourages and visualize. We can verify that entourages in different regions are indeed different. Now that we're happy with the entourages, we can increase the count by a factor of 10 by modifying the factor and multiplying the area of the region. In this example, we will simply take a look at things we need to pay attention to when working with data trees. Here, we have an undulating surface loaded into Grasshopper, and we have populated the landscape with trees following similar steps performed in previous examples. But what if we want to take a subset of the trees and replace it with a person? The key here is to align two sets of input directory with two sets of heights and two sets of points. To get a subset of points, we can do a random split on the points, say a 2080 split. We will store them in two separate branches in a data tree using intertwine. Here, we see a new hierarchy created, with each branch storing each set of points. We can perform the same operation for heights. We can put the randomized tree heights into one branch and add a 5.7 feet average person height in a separate branch. We can then intertwine them. We'll also change the input number of random heights to the number of trees after the split. Lastly, we'll add another directory to path. Currently, path is a list of two items. To ensure the path hierarchy is lined up with heights and points, we'll graft it, which essentially turns each item into its own separate branch. Now let's load them up and see it in Rhino. In these last two examples, we'll take a look at some practical usage of Auto Entourage in both architecture and landscape visualizations. Say we want to show people and trees in the visualizations of an urban street. Here, I have an urban street model preloaded in Rhino. Our goal is to populate the sidewalks with pedestrians and to add trees to the planters flanking the sides as well as in the middle of the street. Here, we have loaded two Auto Entourage modules, one for pedestrians and one for trees. Following similar steps in the previous examples, we can quickly populate each region with around 50 pedestrians. Again, to prevent entourages on both sides looking identical, we can supply two random seeds for each region. For the trees, we want to distinguish those lining the sidewalk and from the ones in the center of the street. To do so, we once again intertwine the two sets of points to create a hierarchy. as well as specifying two sets of ranges for the random heights. Notice that we have to graph the domain such that it corresponds to the steps. We will also double check to make sure that image height also corresponds to point. With all these set, we're ready to load them into our model. In Rhino, I have prepared a set of named views illustrating the design from various angles. We can simply go to each view and reorient our entourages. Now we're ready to render away. In our last and also the most involved example, we will use Auto Entourage to generate visualizations for a landscape planting scheme. Here is a set of curves roughly denoting various planting regions. These regions are already stored in a Grasshopper data tree, with each branch containing 4 regions. Contrively, say we want to visualize trees with similar heights in each region. Thus, our goal is to transform both the path input and the image height input so that they correspond to the regions in each branch. We will again use populate geometry to generate a set of points. Here, I have a list of 4 numbers and they're graphed to match the 4 branches of regions. Notice that the output contains 16 branches, essentially turning each region inside a branch as its own branch. Recall that data trees are basically lists of lists of lists. Here, we have 4 lists, within each 4 more, and within each of which stores 1 region. Since our concern is to populate 4 regions with the same group of trees, we can truncate the outermost branches such that there will only be 4 big branches. Next, let's bring these tree groups into Grasshopper. In my Entourage folder, I have grouped the trees by their range of heights, and named the folders accordingly. Back in Grasshopper, we can do a bit of text manipulation to generate the file path input. In a panel, we can list all of the names of the folders under the tree groups directory. We can then concatenate to their parent directory. But don't forget to add a backslash at the end. Whoops, backslash, not forward slash. Voila! We have a list of file paths to each tree group. We will then graph this to make 4 branches and match our input points. Finally, we will create 4 branches of random heights. Each corresponds to both the paths and the points. We will use the good old text manipulation trick again and replace the underscore in the folder names to space to space. This effectively turns them into four domains, which we can then graph to match the number parameter and generate four groups of random heights. With everything in place, we can go ahead and load them into Rhino. We can again verify that the groups of regions in each branch indeed corresponds to the groups of tree heights. Now we are ready to visualize our planting scheme. That's it. Hope you find this tutorial useful. I'm confident that you can hit the ground running and automate away some extraneous steps in your workflow. One last thing to remember is that you're free to load entourages of any kind, from photorealistic to cartoonish to silhouetted, whatever you may need for your visualization needs. And now, back to your regularly scheduled design activities. Cheers!